These are the work solutions for Mechanical Science Sheet 2, Question 2 and Question 4. A certain type of spring has a spring constant of 55 kilonewtons per meter. Two such springs are connected end to end, one above the other, with the top of the upper spring being attached to the ceiling and with a mass of 10 kilograms being supported from the bottom of the lower spring. What is the total extension of the pair of springs due to the mass being supported? So the equation we use is F is equal to kx. F is the total force, so that's going to be mass times acceleration. K is our spring constant and x is our extension. So if you think about a single spring, you can say that F is equal to K1 multiplied by x1. And for both springs, you can say that the total extension x is equal to the extension in the first spring plus the extension in the second spring. So the bit that can trip you up is how much mass is supported by each spring. If they were in parallel, you could say that they each have a portion of the mass, but because they're in series, the mass acts upon them independently. So the total mass will act on the first spring, then the total mass will act on the second spring. So if you do F is equal to kx for the first spring and get a certain extension, you can just double that to account for the second spring, or you could calculate them separately and say F is equal to K1 multiplied by x1, then do F is equal to K1 multiplied by x2, and then say total x is equal to x1 plus x2. You might have a case where different springs have different spring constants, and in that case, it's better to do them separately and then add them together. But yeah, the main thing is the total mass acts on each spring independently when they're in series, and they have a portion of the mass each when they're in parallel. So for question 4, it says calculate the stress in a wire of circular cross-section 4 millimeters. Calculate the stress in the wire of circular cross-section 4 millimeters in diameter when it supports a load of 1.25 kilonewtons. So cross-sectional area is the bit that might trip you up here. If you think of a wire being like a cylinder, and the cylinder has a circular face, that circular face is the cross-sectional area of that cylinder. So now if you think of a wire, it's sort of like a cylinder. So the cross-sectional area is what you'd get if you were to cut the wire and then look into it. Its circular face is the cross-sectional area. So you can use pi r squared for that. And we have to remember that the radius is half the diameter. And you can plug that into our regular equation for stress, which is force over area. So we've been given our force of 1.25 kilonewtons, and we can divide by area.